Hello, I am Matthew again. Thank you for tuning in. Woo! Ready to do some more math? I know I am. I love math. This is a video about trig substitutions. It's not trig substitutions. Trigonometric identities, and basically an easy way to remember them all. Almost all of them, like the most important ones, by just remembering 3. It's important videos to me because I know in math, up until like when I started going to university, I did not at all know any of my trig identities. And then my Calc 2 class hit and I was like, I have to know them. So what I like to do is derive and not memorize, because you just have a greater understanding for it and you don't actually have to memorize. You just derive each time. But in this case, you do have to memorize, I think, about 3, but they're very easy to memorize. And once you get those, you'll be golden, crisp, woo, spicy. All right, so the 3 that you have to know, I'll put them in red in this top corner. So we got our 3 to memorize, and I would strongly suggest to get these to memory, as once you get these 3, you can basically derive all the other ones, and I think that's a pretty good trade-off as opposed to memorizing stuff and clogging up your head with random garbage that you don't need to know. So I'm going to start off with cos squared plus sine squared is equal to 1, and I'll show you how to derive the other versions of it, I guess, that you might see or need. If you were to take this and divide by cos squared everywhere. So take this side, divide by cos squared x, divide this side by cos squared x. Now, okay, so to do this side, oh my, that does not look like it's squared. To do this side, so you got cos squared x divided by cos squared x, well, that's just 1 plus sine squared x divided by cos squared x. Well, sine over cos is just tan, so you got tan squared x. Now on this side, you got 1 divided by cos squared x. Now, what is 1 divided by cos? Well, that's secant. So you got secant squared on this right side. Wow, you just derived one of them that you should know for the future. Now, instead of dividing by cos squared x on both sides, let's divide by sine squared x on both sides. Sine squared x divided by sine squared x. All right, so cos squared x divided by sine squared x. Well, cos over sine is just cotan, so then cos squared over sine squared x is just cotan squared. And then we have sine divided by sine, well, that's just 1, or sine squared divided by sine squared, but you know. And then 1 divided by sine squared x. 1 divided by sine is just cosecant, so then 1 divided by sine squared is just cosecant squared. And this is another identity that you should know. Just coming from this, you just divide by respective, functions, and you can derive all the other ones. Just think about, I don't know. Yeah, if you ever need it, just divide. Just divide. All right. Like if you need tan, for instance, just think about, how can I divide this equation to get tan? And you're like, oh, I can divide this sine by a cos and get tan, and you just get your equation for that. Or like, if you need a secant, well, how do I get a secant out of this guy? Well, I can divide it by cos squared, you know? That type of deal. So you just have to memorize this base one, and then you could get all the other ones. Cos of A. All right. So with this guy, we can do so many different types of things. Deriving a double angle identity. Well, how do you do that? Well, if you turn this B, instead of it being A plus B, and you turn this B into another A, if that makes sense. So you just replace B with A, and now you're left with 2A because it's A plus A. I'll write that down. That's what I will do in here, and that's A plus A is just 2A. That's one of the things that you can do. You can replace B by A, and you're left with 2A. So sine of 2a, because b is now a, then is equal to sine of a cos of, well, if b is now a, then now this becomes cos of a plus, well, b is now a, so this is just a cos of a. All right. Now, well, it's perfect. Sine a cos a plus sine a cos a, that's equal to 2 sine a cos a. Not bad, not bad, not bad. I guess you can't actually do much with this guy. The cos one you can do a lot with, and you'll see just coming up right up. So that's how you derive the double angle identity for sine, is just replace b with a. All right, now the next, I think the most important one to know of all is, especially for integration in Calc 2, the most important one to know, and you should memorize this, is the cos version of that, where it's like a plus b. You should memorize that guy. All right, now we can do with the same thing that we do with the sine one and replace this b with another a. All right, so now we have cos 2a is equal to, so this b becomes an a, so cos a minus sine a sine b becomes an a, and this is equal to cos squared a minus sine squared a. All right, that's what cos 2a is equal to. Now, with this new guy, we can either go two paths. Because our very first identity that we memorized was cos squared, I'll actually write it down for you to make it much more sense. Our first identity that we had that I wanted you to memorize was cos squared x plus sine squared x is equal to 1. Hopefully that comes up on camera. Now there's two paths that we can take, I said. We can take the cos squared path, where we can replace this cos squared with 1 minus sine squared, because we can just solve for cos squared, or we can take the sine squared path and replace sine squared with 1 minus cos squared. So both are valuable options, and you must replace as you need. But in this case, I need, I'll do both. So I'll do the cos squared one first. So cos 2a is equal to, replace cos squared by 1 minus sine squared, because you just bring this to the other side. So then you got 1 minus sine squared a minus sine squared a. Now this is nothing but 1 minus sine squared a minus sine squared is minus 2 sine squared a. Just collect like terms. And now you got this identity. Perfect. An interesting thing that you can do is actually find what the half angle identity is of sine. And the way that you do that is you can solve this for sine squared. Sorry, solve this equation for sine. Okay. So let's solve this equation for sine. Easy. I guess I'll do this over here. Right here. So in a little bubble. So we got cos 2a is equal to 1 minus 2 sine squared of a. So then sine squared a is equal to 1 minus cos 2a all divided by 2. So then sine a, let's take the square root of both sides, is equal to plus minus 1 minus cos 2a divided by 2. All right? So I said about the half angle identity, right? So you can actually divide this a angle by 2. So then you get a divided by 2 in this angle. And what you do to this angle, you have to do this angle So then you get 1 minus cos, and lucky enough, when we divide 2a by 2, we're just left with a. So we're just left with a normal angle. And that's how you derive the half angle identity for sine e, for sine, yes. All right, we'll do the sine squared root now. All right, cos 2a is equal to cos squared a minus, well, let's bring this cos to the side now instead. We got 1 minus cos squared. 1 minus cos squared a. All right, collect like terms. Okay, so, or multiply this negative in first. So we get minus times minus 1. And then, sorry, minus times 1 is just negative 1. Minus times negative cos squared a is just positive cos squared a, plus another cos squared a is just 2 cos squared a. Perfect. And this is another double angle identity for cos 2a. But now if we wanted to find the, like we did over here, the half angle identity, we could solve for cos and then divide the angle again by 2. So we'll do that over here. I just rushed that really hard because my camera's about to die. Out of those 3 identities, we actually found, I think it was about 8 different identities. So by memorizing 3, we could derive 8 more. So in total, we know 11 off the top of our head, easily. I think that's a pretty good trade-off. In Calc 2, that helped me a lot. In high school, I wish I knew how to do this because stupid trig identities are stupid. And if your teacher tells you that you don't need them in the university and you're going to take math, well, I'm sorry to break the news to you, but you're going to need trig identities. So my name is Matthew. My channel's name is Matthew. What? Isn't that interesting? Okay, see you later. Bye-bye.